Rob Smith from DV Experts International here in Melbourne. I'd like to take a little of your time to introduce and explain the Motorcycle Operator Training Assessor, or MOTA as we've come to call it. Based on a concept drawn from real-world experience, the MOTA system has been designed and built by R&D engineer John McIver. MOTA represents a giant step forward in motorcycle rider performance measurement. Since the 1970s, rider safety training has been evolving constantly and now provides millions of riders worldwide with programs based around the core skills of braking, swerving and riding curves. So far, the ability to measure and record an individual's skill has been almost entirely reliant on an instructor's subjective appraisal or the use of crude electronic devices that fail to eliminate human error. In the early 90s, the State Licensing Authority here in Victoria adopted the Motorcycle Licence Skill Test, or MLST. This test provided a far better method of measurement than anything that preceded it. The MLST introduced random decision and response demands that tested a rider's ability to utilise the collision avoidance and riding skills they'd learnt during training. Even though the MLST required just 60 metres by 40 metres of range to operate and proved to be operationally simple and robust, it is flawed. Being reliant on a stopwatch to measure critical speeds in order to trigger certain functions meant that huge variations between operators existed. In other words, objectivity was lost and test integrity was compromised. Recognising the limitation of the MLST, DV experts focused their energies on developing an entirely objective test that retained the attributes of the MLST but provided high-level consistency, repeatability and, critically, data recording for audit purposes. The MOTA system still provides assessment of the core riding skills and retains the advantage of only needing a range side of 60 by 40. But now, operator variation has been completely removed using high-tech solutions. Using new technology, a motorcycle mounted unit records every movement of the machine, measuring acceleration, deceleration and bank angle. This information is passed to a laptop computer, which in turn talks to a system of lights. Being entirely integrated, the system needs no operator input once the testing sequence has begun. This, for the very first time, has meant that the test is entirely objective. If you think that the MOTA system is just about testing, you'd be wrong. MOTA is a highly flexible training tool. Trainers can select different exercises and use different reaction time settings to tailor training for both novice riders as well as advanced. Being computer-based, it allows all performance data to be stored so that audit functions can be carried out by simple download. This allows both trainers and testing organisations to call up any candidate's records at any time. Security issues are addressed by assigning a tester code to any test carried out, a function that allows the training organisation to monitor training consistency and effectiveness. The operator enables the lights simply by using the computer and is presented by this startup sequence shown on our prototype. By switching on the motorcycle module, the programs are ready to begin. Like its predecessors, the testing procedure focuses on a right swerve, left swerve, braking and riding curves. The green light indicates the test can commence. With enough range area, the system can test at any speed and can utilize existing line markings. The computer selects a random skill test, calling for real-world reactions and responses. Many riders experience difficulties matching speed, lean and curve requirements. MOTA captures not just speed, but path and lean angle for more accurate measurement and analysis. Data is recorded in real time by the computer. The results are instant and performance reviewable in 3D view using the accompanying software package.
The motorcycle test system stores the recorded data in files on the computer disk. It's possible to take these files and review them, and we have a real-time replay program here which can do that. So if we run this and load a braking test, we get some header information about who was running the test, the date and time of the test, and various parameters about the test. We can then view time charts of the various parameters. So here we have a velocity time profile where time is on the horizontal axis and the motorcycle velocity is on the vertical axis in kilometres per hour. We can see the motorcycle accelerates to some maximum speed and then comes to a brake. We can also display other parameters such as distance time or bank angle time or various accelerations with respect to time. Each chart has the ability to draw a line across it and display the parameters at a given time and get an accurate result of the parameter at that point. As well as time charts, we can also do a 3D real-time display. So here we have a display of a 3D motorcycle. We're displaying time during the test, velocity, distance and bank angle. We're able to display the motorcycle from any point of view, and we can also zoom in and out to get our most appropriate view for what we want to see. The 3D display also gives us acceleration arrows in the lateral, longitudinal and normal directions. If we now run the replay, the motorcycle display will run at real time, and this will be analogous to standing watching the test again. So in this case it's a braking test, so the motorcycle kept to its single trajectory. We now load another test, which can be a left turn test in this case, and replay the display. Now find a different point of view and we run that test. We should see the motorcycle perform a left swerve test. So the motorcycle starts, runs left, straightens up again. Finally, for more detailed analysis, we can display, by using the print data function, a printout of the parameters for the test. So we can display the output from one of these, which is simply columns of information where we have time, XYZ position of the motorcycle, rotation angles of the motorcycle, the velocity, distance travelled, radius of curvature, and the 3 accelerations of the motorcycle. And these parameters can be printed out as a simple text file and analysed as required.
So there it is. MOTA is poised to take motorcycle training and testing into the future. MOTA provides the very first objective, repeatable and electronically auditable rider training performance measurement system. We look forward to discussing your needs and expanding on this brief presentation further.